Okay, so we're going to look at the structure of a bone here. And this is just a small section of it. On the outer layer of a bone we've got articular cartilage, and this allows long bones specifically to move around a joint and articulate, so they reduce friction. Your red bone marrow, which is more inside the bone, is a spongy tissue, and this helps to produce red blood cells and white blood cells and platelets. And then in here you've got a medullary cavity, and this simply holds the yellow bone marrow, which is a spongy tissue and helps to produce fat cells and cartilage. Surrounding that is a compact bone around the outer layer, which is also known as cortical bone, but you can call it compact bone. And then to protect that you've got periosteum, which is a tough outer layer. Looking at the full bone then, you've got the proximal end, which is the bit that would be closest to the body. The distal end would be further away. So in this case we could assume this is a humerus. So you can see the articular cartilage around the outside on the top. Okay, you've got your medullary cavity in there, your red blood cells, your blood vessels, compact bone as mentioned, and periosteum. So the epiphysis is known basically as the ends of the bone, which allows the articular cartilage to form around. Your blood vessels are necessary inside a bone, which most people don't think they are, but they're inside of a bone to pick up the new blood that your bone produces. Now your diaphysis is just a fancy word for the longer section of the bone. An important point that may come up in exams is about bone growth. Now the epiphyseal line is quite an important part of that, and you can see a line at the top and a line at the bottom, which just quite simply is where the bone grows from. So it's a disc of cartilage that separates your epiphysis to your diaphysis. Now when growth starts to slow down and stops altogether, this epiphyseal line will close up and stop growing. Then you've got your cancellous bone, which you find as a honeycombed structure, and this is a bit like a crunchy bar, and what makes up the majority of the bone's structure. So people who have a low bone density will have quite large holes in there. People who have a very strong bone density will have very small gaps in that honeycombed structure. So we'll have a quick look at bony landmarks as well. So all the bones in your body have got different little bits on them, and they're normally there to help with muscle attachment. So you've got notches, which you might see as a V-shaped depression in a number of bones. A fossa, which is a shallow depression. Okay, we can see here on the radius. So it's just a small depression in there, and that's where the other bone, just in there and in there, the other bone will rotate around this, and these fossae are where the bone will basically stop being able to move any further. Your condyles, okay, so you've got your condyles just on the outer, so that's your lateral, and you've got your medial, and these are rounded bumps that fit into a fossa, and this kind of forms the main joint, and it's more the structure of the movement. The borders are just the main part of the bone, really. There's nothing really to spot them. Then you've got processes, which are sections that kind of stick out a little bit, a raised area, and that's there for muscle attachment. So a typical one might be on the front of your tibia, which allows you to attach the quadricep muscles to it with the tendon. And the last one is a tuberosity. So at the moment, if you're sat down, you will be sitting down on your ischial tuberosity, which attaches hamstrings and things like that to the body. So that tuberosity is like a projection, quite a rough section of bone to help with muscle attachment.